So here are the 4.7, excuse me, the 4.7 solutions. Again, we're trying to solve by using factoring, so we need to move everything to one side of the equation, having it set equal to 0, and then we start our factoring. So number 11. Since I'm not already set equal to 0, and I've only got the one piece on the right side of my equal sign, I'm going to go ahead and subtract that 4x squared and write my polynomial in descending order. Since I see an x in every single term, I can factor out an x, and now, conveniently, my lead coefficient is 1, so I just need my factors of 4 that add up to -4, so that's -2 and -2. So I've finished my factoring, and since my x minus 2 matches my x minus 2, not only do I know that I now have a double root at 2, I know that I only need to set x minus 2 equal to 0 once. I don't forget my x, set that equal to 0. I've got one step of work to get my x minus 2 to say x equals 2. And again, don't forget to note, it's a double root. 12 is very similar. I've only got one value on the right-hand side, so I'm going to go ahead and subtract that 27y. Write my function in descending order. Again, I see a y in every single term, so I know I can factor y out. And then again, conveniently, my lead coefficient is 1. So I simply need the factors of -27 that are going to add up to +6, -3 and 9. I finish my factoring, set all three pieces equal to 0, finish solving for y in my two problems, and I know that y could equal 0, 3, or -9. Remember, it needs to be an or statement, not and. It can't be all three values at the same time. Number 13. Even though I see 3r squared as a single value on the right, I'm going to go ahead and move the 4r and the -1. That way my 3r squared stays positive. Once I get everything set equal to 0, since my lead coefficient isn't 1, I'm going to go through the process of splitting my middle term. 3r squared times 1 gives me 3r squared. What factors of 3r squared are going to add up to be -4? Well, that's going to be a -3r and a -r. I've split my middle term. I create my groups. From the first group, I can factor out 3r. From the second group, I can factor out -1. I'm left with my matching group of r minus 1, and my remaining piece is 3r minus 1. Now again, factoring is the process we're using to solve these. It's not the final answer. So I still need to take each set of parentheses, set them equal to 0, and solve, resulting in r equals 1 or 1/3. Very similar in 14, even though 6x squared is all by itself, I'm going to move the other two pieces, the 1 and the -x, so that I can have my lead coefficient positive. My function's written in descending order. I don't have a lead coefficient of 1, so I start my process of splitting the middle term. 6x squared times -1 gets me -6x squared. What factors of -6x squared are going to add back together to be +1x? Well, that's 3x minus 2x. I rewrite my function. I make my two groups. From the first group, I can take out a 3x. From the second group, I can take out a -1, leaving me with the matching group 2x plus 1. So I finish factoring. 2x plus 1 times 3x minus 1 is equal to 0. And so I set each binomial equal to 0 and solve, resulting in x equals -1/2 or 1/3. Since I've got a positive 2y squared on the left and my y value, I'm just going to go ahead and subtract 6 so that I have my function set equal to 0. Again, lead coefficient isn't 1, so I need to multiply my first term times my last term to find which factors of -12y squared are going to add up to +1y. Well, that's 4y minus 3y. I've split my middle term. Create my two groups. For my first group, I can factor out a 2y. For my second group, I can factor out a -3, leaving me with the matching group y plus 2. So I finish my factoring, y plus 2 times 2y minus 3. I set each binomial equal to 0, solve for my variable, and I end up with y equals -2 or 3/2. Excuse me. 16 is similar, where I've already got the positive term squared, so I'm just going to subtract 1 so that I'm set equal to 0. Multiply my first term times my last term to get -10t squared, and figure out which factors of negative 10t squared are going to add up to negative 9t. Well, that's negative 10t plus t. I split my middle term, create my two groups. For my first group, I can factor out a 10t. For my second group, all I can factor out is a 1. Leaves me with the matching groups t minus 1. So I finish my factoring. T minus 1 times 10t plus 1 equals 0. Set each of my binomials equal to 0 and solve for the variable, getting me t equals 1 or t equals negative 1/10. 17. Since the 3y squared is already positive, I'm going to move the other two terms since I prefer to have my lead term be positive. So 0 equals 3u squared plus 7u minus 6. I start my process of splitting the middle term, and now I need the factors of negative 18y squared that are going to add up to positive 7. Well, those two values are 9u plus negative 2u is going to equal 7u. So I split my middle term, create my two groups. For my first group, I can factor out a 3u. For my second group, I can factor out a negative 2, so I get my matching group u plus 3. Finish my factoring, set each binomial equal to 0, and then solve for the variable, getting u equals negative 3 or 2/3. And finally, number 18, similar to the last one, I'm going to keep that 6s squared on the right-hand side. Remember, we could even rewrite this once we have it set equal to 0 with the 0 on the other side. We don't need to have the 0 left over on the left. We can move it to the right if we want to. I start my process of splitting the middle term, and then I just need the factors of positive 6s squared that are going to add up to negative 5s. Well, that's negative 3s and negative 2s. Split my middle term, create my two groups. From the first group, I can take a 3s. From the second group, all I'm able to take is a negative 1, leaving me with my matching terms 2s minus 1. And I finish my factoring 2s minus 1 times 3s minus 1. I set each binomial equal to 0, solve for my variables, and I get s equals 1/2 or 1/3. Hopefully this has helped with any questions. If you still have some questions left over, make sure and ask them in class. Like I said before, we're not going to really see factoring go anywhere. We're going to see it for quite a while. See you soon.